Welcome. Today I am starting channel sections. See, channel section is most popularly, it is like this. Usually all the standard channel manufactured is not symmetrical. See, it is symmetrical about x-axis axis. This width will be equal to this width, this thickness will be equal to this thickness. That is standard. But to understand, as usual, first time take random one. See, when you study random one, what happens? Your level of knowledge will increase. You get more grip. So, channel section, some people call C section also. See, like C section, but popularly called channel section. It is like I section only. See, I section has got top flange, bottom flange, web. Here also, top flange, bottom flange, web. I section flange is on either side of web. In channel, flange is on one side. That's all. Okay. Find moment of inertia about centroidal axis, all in millimeter. This is a sketch. 110, 14, 300, 180, 16, 12. Note. First make a note. Moment of inertia. This I have been telling from every class. Now I will stop this one. Some will tell. He is telling, he is stopping and telling every time what to do. Moment of inertia about centroidal axis required. IXX, IYY. So first you should locate centroid G. For that you require X bar, Y bar from reference axis. We will take reference axis here. See, origin O. This way we will take X. This way we will take Y. Then divide into three parts. See, 110 by 14. Then 180 full. See, here the space I want here. This full is here. 180 by 16. And this total is 300. See, total 300. So this depth of web, when you divide, becomes 300, subtract 16, subtract 14, you get 270. See, G1, I'll take 1, exact center. From here, 180 by 2, 180 by 2. This one, half of 12. This G3 is centroid for this rectangle. I think I should shift slightly this side, I think. See, here. Okay, now correct, G3. 110 by 2. Now, this is 110. This is 180. So this offset, if you want, from here to here, this extra offset is 70. From 180, subtract 110. Now, I will not explain this because, note, this question is actually same question as for locating centroid, part 3, lecture 24, question 20. Okay, make a note. So, if you want further more information, you can refer that question. And where, not this way, I wrote formula for X bar, so many things are explained. I even found X bar from that side also, Y bar from top also, I have done. So, start. X bar. Formula you write. See, A1, X1, 180 by 2, X2, 12 by 2, X3, 110 by 2. You can see there. Y bar. Y1, 16 by 2, Y2, 16 plus 270 by 2, Y3, 300 minus 14 by 2 or 16 plus 270 plus 14 by 2. Enjoy, get X bar, Y bar. First of all, this much is also time waste. Okay, start. From here, we got 47.433. See, this is 110. Midpoint is 55. So, somewhere here. This is all important. This is your YY axis. From here, you got right here, X bar. I won't write X bar, I put distance. You write here, X bar equal to, if you are lazy and don't write, you are losing 47.433. So from here, this extreme end, if you want to calculate, from 180, subtract, I noted down there, 132.567. And Y bar, how much I got? 125.783. See, this is 16. This is 270. 16 plus half of 270 is 135 plus 16. 151. But we got 125. So little before G2. So G2 is disturbing me. I want space here. Okay, G2. G2. So little below G2. See. How much below is scale not required, x-axis. And from here to here is your y bar 125.783. Every question I solve, those who are serious work out everything and get tremendous knowledge. Total 300, subtract, I note it down, 174.216. 216 is not possible. If it is 783, it is 217. 217, correct? 7 3 11 8 9 10 11 11 4 5 10 17 27 29 30, correct? Okay. I counted. Okay. That is, see, whenever I want to count something without calculator, or something, I have to do it in my mother tongue. English, I cannot do it. If I want, see, I have what? If you do not know language, 3 7 10, that way, 7 plus 3 10. That is my personal thing. Okay, start. Now, everything ready. We will calculate moment of inertia. I will write here. This I will remove. Question 29 also not required now. Next question 30. I will make a note now so that I will not forget. Channel section I will remove. Okay. Next is question 30. Somewhere here. 30. Okay. Start. Calculation of I about xx and I about yy. Centroidal axis all over. Right. First, by parallel axis theorem, you write I about any axis equal to usual story. How many times I have to tell it? Ig plus a square. A into h square is red color to understand. A into h square. Okay, now correctly start. First, Ixx. This is very important. See, I about xx. Start. Now be careful. Come to part number 1. See, part number 1. Axis passing through centroid parallel to xx. See, this one. See here, 180 into 16 cube by 12. 180 into 16 cube divided by 12 is Ig. Plus area. 180 into 16 is the area into from centroid G1. See, from here to required axis xx, this distance square. See, from here to here is 125.783, red color. The red color is the most important. 125.783. From that, subtract half of 16. That number, half of 16. 16 by 2. That number to be squared. This will give I about xx for first one. Second one, I about its own centroidal axis. See here. Plus parallel side, 12. 12 into height is 270. 270 cube divided by 12 is Ig plus this one bracket here. Okay. Plus area. 12 into 270 is the area into from centroid to here. See, this distance square is 174.217. 174.217 is from topmost edge to here. So from this distance, subtract this distance. You will get this distance. So from this distance, subtract 14. Subtract 14. And also subtract up to midpoint here, 270 by 2. By 2 whole square. Okay, that also over. Plus one more. Last one. I about its own centroidal axis, parallel to xx. 110 into 14 cube by 12. 110 into 14 cube divided by 12 plus 110 into 14 is the area into from centroid to xx, this distance square, 174.217 minus half of 14. This has come more than 100 times now, whole square over. Get the answer Ixx, preferably in 10 to the power 6 millimeter power 4. Okay. See, whenever I write complete expression, I am not wasting time calculating the answer. Suppose I make a mistake, some will comment. Or, why you want answer? Those people who want to make fair copy, you calculate and write the answer. Correctly calculate. Okay. Even in the notes also, whenever I solve completely and every steps are written, and when such a thing comes, there I don't write the answer. I write, leave it, calculate, enjoy it. Okay, start. I. I will tell enjoy. Okay. I. Start. I about Y axis. Start from here. First axis passing to centroid, but parallel to YY, this axis. 16 into full is 180. 16 into 180 cube by 12. 16 into 180 cube divided by 12 is Ig, plus 16 into 180 is the area into from centroid to YY. See, this distance square is 132.567. Always see the most important, I am using red color. 132.567 minus this distance is, this is total is 180, midpoint 180 by 2. 180 by 2 whole square. By 2 whole square. This will give for 1. Come to 2. Okay, plus. Bracket here. Okay. I about YY. First about its own centroidal axis, but it should be parallel to YY. Then parallel side is 270, other is 12. 270 into this is explained 100 times. No one should ask, sir, why it is this to that one? Okay, plus 270 into how much it is? 12 cube, not 10 cube. See, 270. Suppose by chance such a mistake happens later, you change it to 12. Don't make an issue. 12 cube by 12 plus 270 into 12 is the area into from centroid to YY, this distance square. Question number 29. I already told the distance, and earlier that's a master question, some explanation. These principles solve, I might have told more than 200 to 300 times now how to calculate. Plus area into, see, this distance square. 47.433. 47.433 is this distance, subtract this distance, minus 12 by 2 whole square over. Okay, now lastly, plus I about YY. First about axis passing to centroid, parallel to YY is here. See, this axis. 14 into 110 cube by 12. 14 into 110 cube divided by 12 Ig plus 14 into 110 is the area into from centroid to YY. See, this distance square. That is, see, from here to here. What to do is look that side. See, from here to extreme end is 132.567. 132.567 is from here to extreme end. Subtract 70. Again subtract this distance, that is 110 by 2. That one whole square. Or you can do one more thing. See, or from centroid to this extreme end is, this is 110 by 2. 110 by 2. From that one, subtract 47.433. 433, correct? Yes, that also will do. Instead of this distance square, both are same. See, you can do that way also. Your choice. Make a note. Over. Now, question 30 over, 29 over, question 30. Okay, 1 minute. Question 30, I will write and explain to save the time. What I am going to do now is, I took, see, 110 here and 180, this is 14, this is 16. Now I am using standard channel section, means flange, both the flange are of same width and same thickness, means amount of work is reduced. One symmetry axis will come. So amount of work will reduce. Once you understand this question, that becomes more clear. Question 30. Find moment of inertia about center of the axis, all millimeter. See, 150, 12, 12, 250. This thickness they are not given. But what they told is, see, the outer is 150, inner is 140. Be very careful. Instead of giving thickness, some other way they are given. Okay, leave it. Start. First, you have to make a note. Divide into parts. See here. See, horizontally divide. 150 by 12. 112. 150 by 12. Same. Here. This thickness requirement, vertically, see, you divide like this, you write there. We are going to divide like this. This way dividing. This is 250, okay, 250. What about this thickness? How much? See here, this is 150, this is 140, means this thickness is 150 minus 140 equal to 10. Remember, 10 is calculated, be careful. This 10 is not given, it is carefully calculated. Okay. 10 is carefully calculated. Okay, over. Now, make one more note. This is this channel, see here. This channel, this width equal this width. This thickness equal this thickness. So, it is symmetrical about x-axis. This is axis of symmetry. Total depth is 274. How you got it? 250 plus 12 plus 12. If there is 274, each will be half. See, 274 by 2. This also is 274 by 2. Therefore, x-axis you need not locate, means y bar is not required. We have to locate only y. So, x bar required. So, this time, x bar only required. You take reference here, see, through this extreme edge here, I would call the axis AB. Now, origin all not required. Why? Only one distance required, AB. Start. To locate y axis, x bar, formula is already there. This area, see, 150 into 12 into 150 by 2, A1, X1. Now, be careful. See, if I see 3 here, once again 150 by 12, once again same distance. So, multiply by 2. Multiplying by 2 is, that is for part number 3. This is for part number 1. See, A1 x1, A3 x3, then A2 x2. 10 into 250 into 10 by 2. Divide by total area, you get 46.311. Mark here, 46.311 is, this is 150, center is here. See, it will be here. This is your y axis. B, go that side. B. This is your x bar, 46 point, how much? 311. Okay, y. Don't disturb me. Okay, then if you want from other side, it will be total 150 subtract, I noted down, 103.689. Okay, this is ready. Now, moment of inertia. Those who are sincere, those who want to learn, write calculation of moment of inertia about centroidal axis, once in a lifetime, you make fair copy. It may take some time now, but later when you refer, everything will be there. In spite of me telling that way, some people won't make that note. Ixx, Iy both are required. Parallax theorem, I about any axis equal to Ig plus A square. If you want to explain everything, start Ixx. Because this is actually more than 200 times now. Start. Figure 1. I about its own axis. 150 into 12 cube by 12 plus 8. Sorry, I have not marked xx only here. See, xx will correctly pass here due to symmetry. Xx will come here. Xx, and I can tell it, you go and get out from here. Don't disturb me. From here to here is, I told, 274 by 2, 274 is 137. 137, this also 137. From top also 137. Start now. I about its own axis over area into from centroid to xx. See, this distance square is 137 minus 12 by 2 whole square. Now, see, this is for 1. Remember, this is what we have done here is, this is for 1. This into 2 is for 3. Why? Because even here, see, I about its own axis. Once again, same. 150 into 12 cube by 12 plus area into this distance square, same as this one. So, once you find, you can make a note. I about xx for 1 equal to I about xx for 3. So, into 2 will do. Otherwise, write once again. Lastly here. I about its own axis. Oh, centroid lies in x axis. So, 10 into 250 cube by 12 plus area into 0 square. I told this y 0 square not once, 10, 15 times. I told in one class only. Okay, calculate the answer. I about y axis. First about, see, its own centroidal axis. Not red color, either green or black, this axis. 12 into 150 cube by 12 plus area into, see, this distance square is 103.689 minus this distance is 150 by 2 whole square, or 150 by 2 minus 46.311. That also will do. Then for here, I about its own centroidal axis. For 1 minute, once you calculate, here also multiply by 2 because this is for 1. What I wrote is for 1. Multiply by 2 for 3. See here, once again same thing here, but you cannot do it if it is not symmetrical about xx. Start. I about its own axis. 250 into 10 cube by 12 plus area into from centroid to xx. See, from here to here, this distance square is 46.311 minus 10 by 2 whole square. So simple, you can calculate. Okay, now I will do one thing now, question 30 over. Question 31, what I will do is, see, I will give a channel section now, see. Question 31. I will tell you what I am going to do now. But I will write first, question 31. I will take a channel this way. This way. Symmetrical. What I will make is, this I will make 400. This I will make 100. This I will make 100. And this thickness and this thickness I will give because I will tell you why. I will select a channel which is there in the IS handbook. I have selected ISMC 400. That all you don't bother. ISMC 400. This thickness property I don't know. So like last time, I will turn the channel here to understand. This question, I will write the dimensions and I will note down the values from IS handbook because it is a rolled section. What values are printed in the IS handbook, what you are getting, minute difference I told because here you take rectangles, their curvature is there. Okay, I'll like last class. Now, question 31, it is pure exercise for you. I will not write anything, I will dictate only. Question is, find radius. See, never see anything here. This is my reference. I will tell you later. You see, you first see here. Find radius of gyration about centroidal axis. Serious. R about xx, R about yy required, R about xx equal to square root of I about xx by a, R about yy equal to square root of iyy by a. So first you require area and also you require I about xx, I about yy. So locate xx, yy and xx is symmetry is there. So direct location xx, yy you have to locate by x bar. So divide into parts. 100 by 15.3. See, again same here. See, this full is 400. Subtract 15.3 twice, you will get 369.4. Okay, now figure 1, figure 2, figure 3. A1, from, see, take reference axis here. From this extreme edge here, take reference AB. Okay, little sketch is not fully clear, no problem. AB. Start. X1, 100 by 2. X3 also 100 by 2. X2 is 100 minus 8.6 by 2. Get X bar. So you are first also calculate area. See, first you calculate area. I write here. You write all the calculation because first of all I should give only answer. Still, I will help those who got difficulty. See, first calculate area. Total area. Area will come. I noted down there. 6236.84 mm square will come. Then calculate X bar from which one? From AB. From AB. Calculate. You will get 73.278 millimeter. Locate. 73 means somewhere here. See. From here to here is 73.278, or from that side it will be 26.721. 722, not 721, 722. Okay. 26.722, not 721. Because 8 means it is actually 2. Noting down. Okay, now. Now, x-axis axis directly locate through centroid. Oh, okay, little upper side. Okay, okay. Little upper side. Centroid here. Okay. Respect to mathematics. Okay. This is central. See, this is actually your G1. This is G3. G2 coincides here. See, this is your x-axis axis. No distance calculation required. From top to bottom and bottom to up here is total 400, 200, 200. Okay. Okay. Now get this much. Then I about x-axis axis. 100 in, I will do here 100 into 15.3 cube by 12 plus area into this distance square 200 minus 15.3 by 2 whole square into 2. Either do for 1 or do for 3 into 2. Why? Take a double plus I about its own axis. Here 8.6 into 369.4 cube by 12 plus area into 0 square. You calculate I about xx. Your I about xx, if you calculate, will come 149.4. 149.4 10 to the power 6 millimeter power 4. Same way, calculate IYY. See, first about its own axis. 15.3 into 100 cube by 12 plus area into this distance square, that is 73.278 minus 100 by 2 whole square into 2 plus I about its own axis. 369.4 into 8.6 cube by 12 plus area into this distance square is how much? 26.722 minus half of 8.6 whole square. It will come 5.825 10 to the power 6 millimeter power 4. Then happily calculate R about xx and R about yy. Whatever Ixx you got here, divide by the area, take root, Rxx will come 154.772 millimeter, Ryy will come 30.561 millimeter. Okay, over. Now, 1 minute. Now make a note. Leave it. This is my calculation. Make a note. Those who are interested in steel structures. Actually, this section is standard section taken from IS handbook, ISMC 400. That is, total depth is 400. See? And for that, breadth of flange is given 100. I have given 100 only. Thickness of flanges is 15.3. He has given 15.3. Web thickness is 8.6. Yes, he has given 8.6. Then, there, see, I told you, curvature is there. Therefore, slightly higher area will be there. No problem. Handbook they printed area 6293. We got 620, correct. See, reasonable. Suppose you have to give somebody 6,293 rupees. By chance you tell him, I got only 6,236 rupees. That's all. That is some 30, 50 rupee difference is there. He may tell, okay, no problem, done it. Give some other time. Here not give some other time, leave it. Then they told, see here, CYY. See, in the IS handbook, I turned the channel. It is turned this way. They told this distance CYY is 24.2. See, this distance is actually this distance Y from here. We got 26.722. They told 24.2, around 2 mm more. Okay, then IXX they told 150.828. We got 149.4. Okay, reasonable. IYY given 5.048. We got 5.825. Slight difference is there. Because there that curvature area is considered. Lastly they told RXX 154.8. We got very nearly, see, 154.772. RYY 28.3. Little more we got 30.56. Make a note. Over. Now channel section over. I decided yesterday. See this course, if I keep on now, see, sometime they can give inverted channel this way. Again, one's unsymmetrical. See, once I'll give unsymmetrical here. Inverted channel. Then I'll give symmetrical, inverted channel. Then one more this type. Now I decided now. Yesterday I decided. If I keep on doing that way, this course will go for a long time. Yes, you can do it. See, anybody all those who studied from me, everything understood. Why? You divide into parts and do it. You can do it. Nothing is there. We have done critical questions. So now decided now, such questions, see, examination sometimes they ask. So all these I decided to give in the notes. I decided those who take notes from me, they should have some advantage. Yes, it is genuine reason. See, it is not that I am telling you take the notes like that, but I should give some advantage for the people who got more confidence in me and take the notes from me. Therefore, yes, see, but anyway, see, this all I solved here. I will not do any injustice to subject. I will solve so many questions, but same thing, repetition, turned this way. Once you know the principle, anything you can solve. So right now I decided now. Up to now, I thought lot of time is spent. So many questions are solved. Now I am reducing because too much lengthy course, nobody is going through it also. Therefore, I decided let the people understand everything. Now I will make one extra class for this one now. Let people understand. So that once you understand what all I do here, any question you can solve, I will bring to that level. So extra benefit will be for those who take the notes. But I am not telling now that everybody you take the notes like that. See, I should give some benefit. I think it is justified. Okay, channel over. Now next I am going for, I don't remember now, a box section I go for. See, that also actually people will tell we can solve. See, you can solve one symmetrical, one not symmetrical. No, a symmetrical already over earlier. Shortcut method is there, but still I will take up this box section next class, and then I will introduce triangles. I will start introducing what triangles are. I may take one more question called some F section or E section, see, for understanding correctly. One important question this way. See, this way. So that you understand full concept. See, when you divide into parts, you divide like this better. See, divide this way. 1, 2, 3, 4 parts are there. See, here all IG is very careful. So I will take one question of this type for a thorough understanding. I will write there for a concept purpose or some one exercise I may give. See, F section. This way. Exercise I will give. Then I will start introducing triangle, the cutout areas, then semicircle, circle, quadrants, all will come. Lot of classes are still pending. Okay, now go through everything. We'll meet in the next class. Thank you.